There are so many discoveries in science that came out to be accidental. Those were accidental discoveries. Like radioactivity, it was also accidental discovery. In organic chemistry, there is an interesting story about the accidental discovery of thiophene. It was the time when chemistry subject was not so much developed. There were no such spectroscopic techniques to analyze compounds, what we discover or what we synthesize. So generally people used to do different color tests for identification of different compounds. At that time there was a famous scientist named Viktor Meyer. We chemistry people know him very well for the famous Viktor Meyer test that is used for identification of primary, secondary, tertiary nitro compounds or alcohol compounds. So Viktor Meyer that time in a classroom one day was trying to demonstrate a color change reaction. It was known that when you add benzene with isotene in presence of sulfuric acid, so benzene plus isotene plus sulfuric acid, in this reaction the reddish pink color of isotene gets changed into blue color. So this was a known test that time for identification of benzene, or you can say identification of isotene. So that color changing technique was known. This reaction was known that time, that this changes color to this. Okay, so this simple experiment, it was demonstrated in his class by Viktor Meyer. So what happened when he mixed the reaction up and put the reaction, he found that there is no color change, and students found it very funny that professor is showing one reaction and he was saying that the color change will occur, but surprisingly there was no color change, and the students make fun of him that professor showing reaction is not working. And Viktor Meyer was very much surprised that this reaction should occur, this is a known reaction, known color change reaction, why is it not working? Students found it very funny, but not Dr. Viktor Meyer. So what he have done, he asked his assistant that what may the fallacy here, that how is it the known reaction is not working. And he asked his assistant that from where you have given me this benzene. His assistant said this is not commercial benzene. Generally benzene is extracted from coal tar. So from coal tar the benzene we obtain, that is commercial benzene. So professor was expecting that this is commercial benzene, but his assistant said that commercial benzene is not here, not available right now. So I have given you this benzene sample from the decarboxylation of benzoic acid. That time chemistry was developed so much that decarboxylation of benzoic acid was known. So decarboxylation of benzoic acid gives benzene. So assistant of Viktor Meyer gave benzene sample for that experiment from the decarboxylation of benzoic acid, and it was not commercial benzene. So after few experiments it was found that professors found that actually in commercial benzene there is some impurity of another aromatic compound, that is thiophene. Actually thiophene is reacting with isotene to give the color change, not benzene. When benzene was extracted from commercially available coal tar that contains thiophene, but decarboxylation of benzoic acid that is giving the sample of benzene where there was no isotene, there was no thiophene impurity. It is not possible impure thiophene there, right? So from two different sources, where with benzene there is thiophene impurity that is giving color change, and another source where it is pure benzene that is coming from benzoic acid, there is no thiophene impurity and that is not giving color change. So it's very obvious that the compound responsible for the color change of thiophene is not benzene, it's thiophene. This is how thiophene was discovered first by Dr. Viktor Meyer. Thank you.